السلام عليكم ورحمة الله وبركاته. ازيكم يا شباب، عاملين ايه؟ يا رب تكونوا بخير وصحة وسعادة. Today we will start answering Avogadro 2024 chapter 1 transition element lesson 1 from question number 66 to question number 92. Question number 67. A, B are two elements from the first transition series. Can be used in metal plating. Okay. When he mentioned word metal plating, you should know that the common element that used in metal plating, they are two. First, chromium 24, second, nickel 28. Okay. If the number of electrons in the outer main energy level, number of electrons in the outer main energy level of A is more than its number in the last main energy level of B. The outer main energy level equal in meaning the last energy level, the last main energy level. They equal to each other. So firstly, you should make electron configuration for chromium and nickel. Chromium 24, electron configuration will be argon 18 4s1 3d5. Nickel 28, electron configuration will be argon 18 4s2 3d8. You should focus on one thing. Outer main energy level or last main energy level, they are the same in meaning, and you should determine that in these two examples. The last main energy level in the chromium will be 4s because it belongs to the 4s principal level. Okay, and the same in nickel 28, it will be 4s. They are the outer main energy level or last main energy level for two elements. Okay, then he asked in the question, if you know that the main energy level of A main energy level of A is more than in B, that means that 4s sublevel in A is more than 4s sublevel in B. That will make indication for that chromium will be 1, nickel will be 2. So which one of them are more than a number of electrons? Is 4s2 in nickel 28. That means that 4s2 will be referred to symbol A, and 4s1 will be referred to symbol B. So you know that 4s2 3d8 will be nickel and 4s1 will be chromium, and he asked about the symbol B or a non-B, so it will be chromium 24, and our correct choice will be choice number B, chromium. Question number 68. The color of glucose solution before adding filling solution to it is. We know that we use filling solution as indicator for glucose solution. So the color of filling solution is blue, and after adding glucose solution turns into orange. So the change in color is belong to filling solution, not glucose solution. So glucose solution will be color less. So the right question is letter number C. Question number 69. The element that ends by with electronic configuration 6s2, 5d1, 4f2 is from which one of these choices? Okay, as we mentioned before, we have two possibilities. The first one, when D sublevel contain electron or field in sequence with electron from 2 to 10, and F sublevel is completely filled with 14 electron. So this electron configuration, whatever 5d, 6d, or whatever 4f, 5f, as example will be shown in the question. Okay, but the important note that D sublevel, if field in sequence with electron from 2 to 10 electrons, and 4f is completely filled with 14 electron. So this electron configuration refers to element in D block element. Okay, so what? Second transition series, third transition series, fourth transition series. Okay, but this element will be belong to D block element, especially third transition series and fourth transition series. Okay. On the other hand, if the electron configuration of D sublevel is contain only one electron, okay, and F sublevel is filled in sequence with electron from 1 to 14, maybe 1, 2, 3, 4 until you reach to 14 electron. So in this case, element belong to F block element. Okay, and maybe in lanthanides and or actinides, and that depend on the principal quantum number for F. If you have 4F, so you will be located in lanthanides, and if you have 5F, it will be located in actinide. Okay, that two most important notes you should take in consideration, and you should write it to your notebook. Okay, let's restart rereading the question and answering. The elements that end by with electron configuration 6s2. Okay, focus on two things. Focus on D sublevel and F sublevel. You found that D sublevel contain one electron, K, and 4F sublevel is filled in sequence with 8 electrons and not completely filled. So this is resemble or the same as the first case, which you have D1 or F sublevel may be filled in sequence from 1 electron to 14 electron, and one of these possibilities that is F sublevel contain 8 electrons. So you know that this element or this electron configuration will be belong to F block element. So lanthanide or actinides, it will be depend on the number of principal quantum number for F sublevel. In this question, it has 4F, or the number will be 4. So the number will be 4. This element will be belong to lanthanides. So the correct choice is choice number C. X, Y, and Z are three consecutive elements in the same transition series. Word consecutive equal in meaning in sequence, or continuous or ممكن اقول بالعربي متتالية، واحد ورا التاني. تمام. if x less than y less than z in atomic number, you should take in consideration that sequence. We will make it as he mentioned in the question. Okay, the least one x, then y, then the highest one will be z. Okay, and this element found in period 5 is the key word of this question. Found in period number 5. Element Z used in making rechargeable batteries. Rechargeable batteries consists of two elements, nickel 28, cadmium 48. Okay, you know that nickel 28 in first transition series. Okay, that in period number 4, and cadmium in second transition series in period number 5. So you will accept nickel because he mentions that Z in period number 5. So Z will be cadmium 48. And you know that this element is in sequence as ascendingly. Okay, this sequence as ascendingly. Then element Y is located in group number. He asked about element Y. Okay, if you know that in our periodic table, and the last one will be cadmium Z. So the one will come before it will be Ag silver 47. Okay, if this is cadmium 48, Y will be silver 47, and silver 47 located in group 1B. So the right choice will be letter B, group number 1B, and the element Y is referred to Ag47. Question number 71. If the electronic configuration of ion of element M is argon 18 3D1, then this ion is, okay, we have four choices. Choice number A, M22 positive 3. Firstly, we will make electronic configuration for M22 will be argon 18 4s2 3d2. Okay, in choice number B, you have M22 will be 4s2 3d2. Choice number C, you have M23 argon 18 4s2 3d3. In choice number D, M21 4s2 3d1 in electron configuration. Okay, so he asked about oxidation state positive 3. So we will lose 2 electrons from 4s, it will be 0, then 1 electron from 3d, so it will be 3d1. So he asked about argon 18 3d1, and this demanded as a question in choice number B, choice number A, sorry. Okay, but we will complete the other choices. Okay, M22 will be oxidation state positive 2, argon 18, lose 2 electron, 4 is 0, 3d2. In choice number B, 3d2 is not equal to the demanded in the question 3d1, so it will be wrong. M23 in oxidation state positive 2 will lose 2 electron, and 3d will be 3dc and 3d3, and he asked about 3d1 in the question, so we will accept choice number C. Choice number D, he asked about oxidation state M positive 3 argon 18, as we know 4s 0 3d 0, so 3d contain no electron, 0 electron, and that is not equal to the demanded in the question 3d1. So question D will be accepted. So the right question will be the right choice will be choice number A, M positive 3 22. Question 72. The cation compound VO2 is formed when losing. Okay. Firstly, you should calculate the oxidation number. Okay. By making an equation. Vanadium is unknown element plus oxygen minus 2 by 2 equal 0. Okay. That's minus 4. Minus 4 will be with positive sign. It will be positive 4. Okay. Firstly, you will make electron configuration for vanadium in atomic state 23, argon 18, 4s2, 3d3. Okay. Then you will make it in oxidation state positive 4. It will be argon 18, 4s0, and 3d will be losing 2 electron, so it will be 3d1. Okay. In vanadium positive 4, you will be lose 2 electron from 4s sublevel and 2 electron from 3d sublevel. Okay. Let's read the choices. All electrons of 2 sublevel, no. 2 electron of 4s level, okay, sublevel, and 2 electron of 3d sublevel, yes. That correct choice. That refer to the demanded in our question. 2 electrons of 4s sublevel and 2 electron of 3d sublevel. So the right choice number B. Question number 73. The transition element that is characterized by half field 4s sublevel, 3d sublevel is, okay, 4s sublevel is half filled when it will be 1 electron, and 3d is completely filled with 10 electron, and he asked about half filled, so it will be half filled with 5 electron. Okay, this electron configuration 4s1 3d5, according to nearest noble gas, it will proceed with argon 18. So argon 18 4s1 3d5, this electron configuration refer to chromium 24. So the right choice will be letter B. Question number 74. An element with atomic number 111, then, okay. First, you should make electron configuration. So the nearest noble gases to the atomic number 111, it will be radon 86. Okay, radon 86 will be follow with sublevel 4s, then 5f, then 6d sublevel, then 7b sublevel. Okay, let's make our electron configuration by putting electrons for each sublevel. Okay, you know that S contain or completely filled with 2 electrons. Okay, 86 plus 2 will equal 88. Okay, and you know that 4f is completely filled with 14 electrons. Okay, 88 plus 14 electrons, it will be 102. Okay, from 102 to 111, the difference will be 9 electron. Will be 9 electron. If you minus 111 from 102, it will be 9 electron. So D will contain 9 electron, and this electron configuration will end with 118 electron. Okay, in this case, if you have 7s completely filled and 6d end with 9 electron, so this is anomalous electron configuration in which 7s will be half filled and 6d will be completely filled to make extra stability for this atom. Okay, he asked it in the first choice, it's similar to element with atomic number 19. Yes, because element with atomic number 29 will be copper 4s1 3d9. So the electron configuration is the same, 1 and d will be 10. So it resembles to the atomic number 28 electrons. Okay, in the electronic configuration. المفروض الجزء ده يبقى متزود عليه بس كمان word electronic configuration to be accurate. Its 6D sublevel is successfully filled. Yes, successfully filled with 10 electron. Choice number B is correct and choice number A is correct. Main transition element. Yes, as we mentioned before in the preceding questions, when you have 5F completely filled and d orbitals successfully filled from 1 to 9 or to 10, so it's belonging to main transition element. So correctly, this element is belonging to main transition element, so all the previous is correct, so we will choose letter D. Question number 75. The elements of the second transition series lose electrons of sublevel. Okay, the second transition series refer to period number 5. Okay, and in period number 5, the electronic configuration will end with 5s from 1 to 2 and 4d from 1 to 10. Okay, this is the electronic configuration. As we mentioned before, that the last or the outer main energy level will be 5s. You know that the end of the sublevels will be almost 5s. Okay, so when he lose electron of sublevel, we will lose from the farthest way from or the further sublevel from the nucleus, it will be 5s. So we will choose letter D. Question number 76 is transition element with electronic configuration krypton 5s1 4d5 is. He asked about the location in the choices. So to calculate the location or to find the location of the element in the periodic table, if you have s and d electron, you should make addition process by plus the electron of s, 1 electron, plus the electron in d sublevel 5, so 1 plus 5 equal 6 number, and you should end with letter B because your electron configuration end with d sublevel, so it must be end with letter B. So this located in group 6B, and that will be achieved in choice number A. Question number 77. If you know that the ion of element X positive 3 causes a sublevel 4D to have 5 unpaired electron, so the atomic number of X atom. Okay, first you know that when 5D have 5 unpaired electron, so it must have 5 electrons only. Okay, and that in oxidation state positive 3. You know that when you talk about ions of element in main transition element, must 5s will be 0. Okay, he asked about atomic number for X in its atomic state. Okay, return 3 electron back to its sublevels. Okay, 5s will take 2 electrons, then 4d will take the last electron, so the number of electrons in d sublevel will be 6. Okay, you know that the nearest noble gas in this case will be krypton 36. Okay, to calculate the atomic number plus the electron of noble gas plus electron in 5s sublevel plus electron in 4d sublevel. Okay, so you have 36 plus 2 plus 6 will be 44. So the letter C will be correct choice. Question number 78. If you know that the electronic configuration of a trivalent element. Okay, let's refer it to a symbol X plus 3. That means it's trivalent element. Is argon 18 only. Okay. Argon 18 is a noble gas and follow with 4s sublevel and 3d sublevel. Okay. And this electronic configuration, argon 18 4s 3d, it's belong to main transition element. Main transition elements, especially first transition series. So the correct choice will be a main transition element, letter D. Question number 79, you have the electronic configuration of 4 different elements, A, B, C, D. Okay. Which pair of elements are similar in properties? Similar in properties have two possibilities. It will be in the same group and in the same period. But in most cases in periodic table, as first choice will be in the same group. Okay, not in the same period. Okay, let's start. Focus on choices and apply it to the text of the question. Which pair of elements are similar in properties? A and D. A located in group 4s2 3d 6, okay, in group 8. And D 4s2 3d 7 by adding 2 plus 5, it will be in group 7b. So they are not in the same group and same period. A and D is repeated again, so it will be accepted. Okay, A and C. A and C not in the same period because it's 4s and 5s, so it will accept it. So B and C, B and C located in the same period, period number 5, and in the same group, group number 8 in periodic table. As we see, it will be 46 rhodium and ruthenium and rhodium, 44 and 45 elements, and these elements are in the same period and same group, so the similarity in properties will be most common. So letter C will be correct. Question number 80, the electronic configuration of the last transition element. Okay, the key word of this question, last transition element. In the period number 5 end with, okay, period number 5, you know that important note that group 2b, it's not transition element. You should accept that from our choices. So the last one will be AG47. The last transition element is the period number 5. Electronic configuration will be to the nearest noble gases, krypton 36, 5s1, 4d10. And this electronic configuration resemble to letter number C. Question number 81, the element of the electronic configuration end with 7s2, 6d2, 5f14. Okay, we mentioned that note before. If you have D successfully filled in sequence from 2 to 10 electron and F is completely filled with 14, this electronic configuration will be belongs to main transition element, whatever number of transition series. And if the electronic configuration of D contain only one electron and sublevel F is successfully filled from 1 to 14 electron in sequence, meaning in sequence you have many possibilities like 1, 2, 3 or 4 until you reach to the end of the electrons. In this case, this element belongs to inner transition element, F block or F block elements. Okay, so this electron configuration in our question, you have D start contain 2 electron and F sublevel is completely filled with 14 electron. So apply this rule, the first rule or the first note you have. So this electron will be belongs to main transition elements, and the main transition element especially because it's 6D, especially in the 4th transition series. And if it was 5D, okay, it belongs to 3rd, but in our question it's 6D2 and it belongs to 4th transition series in the letter D. Question number 82. Which pair of the following compounds the number of unpaired electron in chromium ion equals the number of unpaired electron in manganese ion? In this question, he asked about comparison between the number of unpaired electron for each one of the following choices. Okay, we will divide our artboard to choice A and choice B. Choice A, we have chromium trisulfate. Okay, firstly, we will calculate the oxidation number for chromium to know the number of unpaired electron. Okay, chromium give sulfate 3 electron. That means after making equation, it will be chromium positive 3. Okay, in chromium positive 3, argon 18, 4s will be 0, then 3d will lose 2 electron. Firstly, we know that 3d will be 5, lose 2 electron, it will be 3. So 3d3, if you draw the orbitals, you have 3 unpaired electron. 3 unpaired electron. Okay. Second compound, manganese sulfate. Okay, oxidation number of manganese will be positive 2 because sulfate is minus 2, so manganese will be positive 2 to make the whole charge of the compound equal 0. Manganese in atomic state 4s2, 3d5. When lose 2 electron, it will be 4s0, 3d5 electrons, drawing d orbitals and distribute our electrons. You have 5 unpaired electrons, and in the first compound you have 3 unpaired electrons, so it's not equal to each other. So choice number A is wrong. Choice number B, we have 2 compounds. The first one chromium oxide and second one potassium permanganate. Okay, oxidation number for chromium in chromium oxide. For chromium oxide, it will be positive 2 because oxygen is minus 2 and chromium will be positive 2. Chromium in oxidation state will be 4s1, 3d5. When losing 2 electron in oxidation state positive 2, it will be 4s0, 3d4. 3d4, drawing the d orbitals and make distribution for our electronic configuration, it will be 4 unpaired electron. Okay, for manganese and potassium permanganate, make an equation. Potassium positive 1, manganese is unknown, plus oxygen minus 2 by 4, and the equation equals 0 by 4 minus 2 by 4. Okay, minus 2 by 4 equal minus 1. 1 equal minus 8. 1 minus 8, it will be minus 7. So manganese minus 7 equals 0. So it will be with positive sign. Manganese oxidation state will be positive 7. Okay, electron configuration for manganese in atomic state condition, atomic state case, it will be for argon 18, 4s0, 3d5. He asked about positive 7, which means that it loses all electron in 3d and 5d. It will be 4s0 and 3d0, and that means it has no unpaired electron. So the first compound has 4 unpaired electron and second has no unpaired electron, so they are not equal to each other. So choice number B will be wrong. Let's take the choice number C and D. For choice C and D, we have two compounds. Choice C, we have manganese dioxide. To calculate the oxidation number, manganese plus minus 2 by 2 equals 0. So minus 4 will be changed with positive sign. So it will be manganese positive 4. Manganese Mn25 in oxidation state. In atomic state will be 4s2, 3d5. Then it will lose 4 electron. It will lose 2 from S, 4s0. Then 2 from D, it will be 3d3. Okay, drawing the D sublevel orbitals, you have 3 unpaired electron. Okay, you have 3 unpaired electron. Okay, for compound, second compound, chromium trichloride. Calculate the oxidation state. Chromium minus 3, it will be 0. Okay, with positive sign, it will be chromium positive 3. Chromium in atomic state, it will be argon 18 for S1, 3d5. When lose 3 electron, it will be for S0. Then lose the other 2 electron from 3d, it will be 3d3. Drawing 3d sublevel orbitals. Okay, distribute the 3 electrons. It will be as the figure shown. So you have 3 unpaired electron also. And choice number C, that achieve the reason about our question that he asked about the number of unpaired electron in manganese ion, and the number of unpaired electron in chromium ion, and that achieved in choice number C. So question number 83, which of the following graphs represents the order of the series X and the number of the period Y of D block elements? Okay, X refer to series and Y refer to D block elements period. Okay, series, it will be first series and second and third and fourth. It will take the number 1, 2, 3, 4. As D block element period will take the number range from 4 to 6, maybe 4, 5 or 6 or 7, maybe 4 to 7. Okay, let's show that in our figures. X have the number 1, 2, 3, 4. So here it will be 4, 5, 6, 7. Wrong. X 4, 5, 6, 7. Wrong. Okay. X 1, 2, 3, 4. Maybe X1 takes the number 1, 2, 3, 4. Okay. Y takes the number 1, 2, 3, 4. No. Y will take the number from 4 to 7. So choice number B is incorrect, and we accept all the choices B and C and D, and the other one which is correct, it will be choice number A. Question number 84, the following graph indicates the atomic number of 3 consecutive equal in sequence or equal continuous elements X, Y, Z and their oxidation numbers, then possible groups they are found in R. If you look to the graph, you have atomic number on x-axis and oxidation number on y-axis. If you look at element Y have oxidation state positive 7, and this achieved in one element in the first transition series, which is called manganese 25. So Y refer to manganese 25. And he give me information in the question that they are 3 consecutive elements, so X, then Y, then Z. Okay, if you know that Y is manganese 25, so the previous one will be chromium 24 because they are consecutive elements in sequence with atomic number. Okay, and Z will be iron 26. Okay, so chromium located in group 6b, then manganese in group 7b, then iron in group number 8. Okay, let's check our choices. Z group number 8, excellent. Y in group 7b, excellent. X in group 6b. So choice number A is the correct choice, as we know that in 6b in Latin, in Roman number, it will be VIB, and 7b it will be VI2b, and group number 8 it will be V3R. Okay, as the correct choice it will be choice number A. Question number 85, which of the following ions of its compounds is used in treating tinea disease? It's a fungal disease. Okay, it's a fungal disease. You need a fungicide compound, and that we will found in compound magnesium sulfate, in which magnesium has oxidation state positive 2. So letter B is the correct one. Question number 86. The transition element that is used in hydrogenation of the oil, the electronic configuration of its M positive 3 ion. Okay, hydrogenation of ion, it's referred to nickel 28 with the electronic configuration argon 18 in its atomic state, 4s2, 3d9. He asked in the question about positive 3. So nickel in positive 3 will lose 2 electrons from 4s, then 1 electron from 7d. And as we mentioned before, maybe in some books you will found 4s03d7, or in the other books you will not found 4s, and you will found in the choices 3d only. Okay, and this is found in the letter A, argon 18, 3d7. Question number 88. The following table shows some compounds of transition elements with virtual symbols A, B, and C and their uses. The compound A, manufacture of dyes, refers to chromium and chromium trioxide. Question B, as a catalyst in making magnets, in its vanadium in V2O5. Compound number C, as a fungicide in water purification, it refers to copper in CuSO4. Okay. Oxidation state for chromium is positive 3. Oxidation state in vanadium is positive 5. Oxidation state of copper is positive 2. So the correct arrangement, he asked about the arrangement of ions of these compound. Okay. Firstly, chromium positive 3, it will be argon 18, 4os0, and 3d will be 3. So it have 3 unpaired electron. Okay, V5 oxidation state, it will lose all electron. We know that oxidation. We know that the atomic state electron configuration for vanadium, it will be 4s2 3d3. In case V positive 5, it will be 4s0 3d0. So it has no unpaired electron. Okay, copper +2. Copper atomic state will be 4s1 3d10. When lose 2 electron, it will be 4s0 3d9. And has, when you draw the electronic configuration for d sublevel in d orbitals, it will be has 1 unpaired electron. Okay, so we asked about the arrangement of ions according to unpaired electron. We know that chromium A, vanadium B, copper C. Ascendingly, it will be first refer to chromium in A. Okay, it will be A for chromium. Then it has 1 unpaired electron in C. So it has no unpaired electron in B, which is referred to vanadium 5. Okay, let's check our choices and choose one of them. Okay, we will choose A more than C more than B, which will be letter B. Question number 89. The electronic configuration of the transition element X in the compound X2O3 has a 3 unpaired electron. So the element, he asked about the element. He gave us the electronic configuration for ion and he asked about the element. And you should focus about this two meanings. He gave us the electronic configuration for ions and asked for the electronic configuration for elements. May be in group in the periodic table. Okay. To analyze this text, you should know that X2O3, that means in X in oxidation state +3. When you make the equation to calculate the oxidation state, it will be +3. So you have an X +3. Okay, when X +3, it has 3 unpaired electron. It has 3 unpaired electron. There are two cases. First case, and that is the most possible one, that you have a 7 electrons in D. So electron configuration for these electrons will be unpaired first, then pairing occur for 7 electron. So you have 3 unpaired electron as he mentioned in the question. So he asked about the element. When you have the element, return back the 3 lost electron. It will be X in atomic state argon 18. So S will take 2 electron, 4s2, and D will take 1 electron, so it will be 3d8. So he asked about the group. Make summation process for 2 electron in the S sublevel and 8 electron in D sublevel. It will be in group number 10, and this is according to modern nomenclature for the periodic table, not the traditional one. As we see, okay, the number in the top is referred to the nomenclature of the group according to modern nomenclature for periodic table. So nickel 28, it will be in group number 10 in the periodic table as modern nomenclature. So the choice B will be the correct in the group number 10. Question number 90. The alloy used in making car springs is composed of vanadium plus steel. Okay, and steel consists of or composed of iron plus carbon, iron plus C, which refer to carbon element. Okay, so vanadium is transition element. Okay, iron is transition element, but carbon is a non-metal one. Okay, so the alloy in car springs is composed of 2 transition element and 1 non-metal. 2 transition element only? No. 2 transition element with 1 non-transition metal? No. Okay, 2 transition elements with 1 non-metal. Excellent, because carbon non-metal, not non-transition metal. Okay, because non-transition metal means that it will be from S or B element. Okay, but carbon especially is non-metal. So the correct choice will be choice number C. Question number 91. The electronic configuration of the transition element Z has 3 unpaired electron. So this element. Okay, when you have 3 unpaired electron, you have 2 cases. One for vanadium 23 will be 4s2 3D, and the electronic configuration for d orbitals it will be 1, 2, 3. And the other case, on the other hand, cobalt 27 will be argon 18, 4s2 3d7, make electronic distribution in the d sublevel orbitals, unpairing firstly according to Horn's rule, then pairing will occur. So you have 3 unpaired electron in 2 cases. Let's check our choices. First, letter A, it's oxide in used in some protection cosmetic. This TiO2, not one of these elements, so it's wrong. It used in making nickel cadmium batteries. No one of these compounds are nickel or cadmium, so it's wrong. It used in making artificial joints. Artificial joints is referred to titanium. It's a radioactive isotope used in food preservation. Excellent. It's referred to cobalt 60. It's one of isotopes of cobalt. Okay, so cobalt 27, one of its isotopes, it used in food preservation. So the element will be cobalt 27, not vanadium 23, and the correct choice letter D. Question number 92. The transition element in the first transition series. Focus on word transition element. Okay, and he asked about the least possible oxidation state. So look to the table which we have the most common oxidation state. The least oxidation state of this element, it belongs to copper 29. Okay, in copper 29. So the element he mentioned, it will be copper 29 with electronic configuration argon 18, 4s1, 3d10. So let's check our choices. Okay, he referred to the highest activity and the radius and another choices. Okay, the highest activity in series, no, it is the least activity. Copper 20 is the least one in the activity. Least one in the activity because the arrangement of the activity descendingly from scandium, then iron, then copper. So it's the least one, not the highest one. So choice A is incorrect. The largest radius in the series, you should look to the radius, so to the atomic radius, and the copper. No, the largest atomic radius is referred to scandium 1.4 and copper is 1.17. So it is not the largest, it is the smallest one. Combined with transition element to form bronze alloy? No, because the bronze alloy is composed of copper with tin, and tin is element which is located on B block element, and it is not transition metal. So choice number C is incorrect. So the last choice, make sure that it will be the correct one. Contain one unpaired electron in the valence shell. Valence shell equal outer energy level. So the outer energy level is the highest number of S. So the highest energy level is the outermost energy level or the valence shell level. The three words have the same meaning. Valence shell, outer shell. So in 4s1 it have 1 unpaired electron. Yes. So it is the correct choice. Contain 1 unpaired electron in its valence shell or in its outermost energy level. It's referred to 4s1, which contain 1 electron, so it unpaired electron. So letter C will be our choice. Question number 93. It is the last question but not the least. A, B, C, D are 4 metals and he gave us the characterization for these elements. Okay, first one, a transition element that replaces hydrogen of water. Okay, it's referred to scandium 21. It's highly active element in that first transition series. B is used as a catalyst in making liquid fuel, iron 26. C, form a bronze alloy with tin, is copper 29. A representative element that form an alloy with manganese, it's aluminium 13. Okay. Then to make an alloy characterized by its lightweight and hardness. Okay, lightweight and hardness. This characterization of alloy is referred to scandium plus aluminium. Okay, so scandium has a virtual symbol A and aluminium has a virtual symbol D. So the alloy will be element A with element D. So element A with element D, you will find it in question letter D, so it will be our correct choice. وكده الحمد لله يا شباب نكون انتهينا من حل الدرس الأولاني كامل من كتاب أفوجادرو chapter 1 transttion element lesson 1. يا رب تكونوا بخير وصحة وسعادة.